Hi guys, welcome back to yet another video. Might be a quick one, I think. So since the last video, we've managed to get the org model to actually start generating, but we are generating all sorts of weird and wonderful things. Let's make sure we're recording. We are, and make sure as well we started the clock. So the problem really is that 5 minutes ago, I guess. Excuse me. So the problem is that as you can see here, we're generating C# files, we are generating C++ files, all sorts of things. So I think this is due to profiles not being picked up correctly. So we're having a quick look at the binding transform here. And what seems to be the case is when we look at the binding for the model, well, we don't quite remember what any of this code does, so it's not entirely clear this is doing the wrong thing, but it's possible. So what we thought about doing is to try to look at the existing tests. Yeah, this guy here, so Portuguese keyboard. So we had a quick look at these tests, and let's just do a quick comparison between the Dogen dia. We just enable debugging for this guy here. Perhaps this will give us some kind of comparison point of what we'd expect for the bindings. So whilst this is doing its thing, we will just look here in the logs. Well, I should just come out here, I should think. Well, here we are. So what I'll do is I'll just save this guy. Let's call this org.log. Nope, not quite. Org.log. Right, so that's the org mode version, and if we take the dia version, grab for exactly the same thing, and then if you just put these guys side by side, see if we see any obvious differences. Interestingly enough, it starts off quite differently in the beginning. We are creating a feature group here. Okay, no, actually that's not too bad. Metrics builder, okay, so we start here. Okay, so creating a feature group, that's fine. In fact, to be honest, just to avoid any biases, visual biases, let's just do a quick diff. So if I just compile these two guys. Right, why diff doesn't seem to be having a good day. Oh, actually, no, I know why. Sadly, we can't really diff because in order to diff, we need to take away the timestamps. So that will be a bit harder. So let's just ignore that for a second. So the key thing that really matters is this beginning here. So you see here, configure the base layer. We perhaps start at the top. And then the merge profile is here, accumulated profile is empty. Okay, so that's fine. Ah, there's a difference here. So there is a difference here. We have no profiles found using original, whereas here we start binding profiles. Oh, that's the first difference. Now let's continue because I'm more interested in this. No, actually, to be honest, that might even be the key, because the default profile is this guy. Right, let's just try to understand what are the two possibilities we have here in the code path. So one guy is basically saying this. The other guy clearly must have gone into here. So in both cases we seem to say looking for the default profile, if I remember rightly. But in the case of the new code base, it's interesting as well that we don't really have a return here. This code looks all very suspicious, if I'm honest. Let's try to understand what we're trying to do here. So we're trying to bind. If a base layer profile name was specified by the metadata at the configuration level, it must exist within a profile collection, okay? Locate it, merge it with the original annotation, and return it. This is the case, for example, for the root module, okay? So that's all fine and dandy. So here's base layer false. Configuration DL base layer. So first thing is we obtained the base layer name. Okay, so up to here this is kind of making more or less sense, because as you can imagine we should probably be around here, right? And I bet you if I have a quick look at this guy, here we are, reading the profile name, and then the profile name comes out, okay? So let's just jump back to where we were. As you can see, that's basically reading the profile name and the profile name. Now, we're trying to configure the base layer. So the profile name is not empty, which is good. We obtain... So this clearly must be working, otherwise we'd be throwing. So we found that base layer. Then we call the merger. Set A's base layer to true. Now I'm curious as to what exactly we're doing with this guy here. Okay, so if we found the base layer when we call the handle potential binding links, so what is puzzling of all of this is it's not clear why we're not saying that we've merged the profile. We should be saying, well, we do. Okay, merge profile, merge profile. Commit the profile is empty. No base layer found on all profiles. Now I'm not entirely sure what that means, but so let's have a quick look at what these guys do. Right, so this method manages the merging against a set of potential bindings on a configuration. The process is done in 3 steps. So first we determine which potential bindings can be realized into actual profiles. For the realizable profiles, accumulate all the configuration points which are not related to the base layer. These are stored into the accumulating profile. I don't think we need the underscore here. Finally, merge against the configuration. This must be done in order. First accumulating, well, actually maybe we should probably just leave that. This order is highly non-intuitive. It rests on the fact that, okay, fine, so we don't particularly care about the details, we just want to see what we'd want to expect to see here. So, keeping track of the bind count, the base layer name, some kind of merger. So we create the profile just for the purposes of merging, it's fine. So processing potential binds. Are we processing any potential binds? This requires quite a bit of concentration. I think we lost track of where we were because a second ago I thought I could see a difference between these two, but now, yes, the difference is just this no profile sound using original. It's also interesting that a lot of the profile names are blank. Let's try to fix that. Okay, so basically we are trying to read the profile name and there is no profile name, so perhaps we could just improve things slightly here, say it's only where there is a profile name. We could just say something like profile name field not found. Right, this will just make the logging slightly more logical. Still not very clear why it is that in one case we hit here and in the other we don't. So in fact, I'm not even sure what this line, what kind of value this line is adding, because configured base layer profile. In both cases we have an empty. So all we need to do is try to understand what exactly happens around looking for the default profile, really. This guy here. Yeah, the logging that really would have been useful is this guy here. So found default profile, presumably. And else. Now, I don't understand why we're not throwing, because it seems very bad that you can't find a default profile, but let's try not to break too much of this code, because it's a very difficult code. So what does the logging now tell us? Right, so what we need to do now is we need to regenerate these files. So in fact, I am going to just create two files. Okay, and now hopefully we can just load up the two of them. Actually, another thing we can do, I mean, we're being a bit of, might be exaggerating slightly here, but, so let's say we start at, I don't know, line 20 maybe? See what that gives us a bit more, so let's give another 6, 26 perhaps. Okay. 28. Right, so this will now give us a log. Right, so this is the dia dot log, and this is the org dot log. Okay, so now if I take these two guys again, if I just pause for a second, talk that. Okay, the usual chaos and havoc. So as I was saying, we should be able to just edit these two guys. There will be some differences. Wait up, something is not quite right here. So I think Emacs is ignoring my grep somehow. Showing me a lot more things than I expected, so let's have a look. So grep profile binding, cut me. Not entirely sure why. These are the sort of things that somehow seem to only happen when we're recording. Never had problems before grepping with Emacs. I wonder if it's because we've got a pipe. Sometimes we find weird and wonderful behaviors in Emacs. Let's just call these the Dogen shall say. Right, so what we'll do is we'll do exactly what we just did, but let's just use eShell. Not that I'm not trusting Emacs, but yeah, as you can see here now, it's actually doing the right thing. So we need exactly the same command line with a slight transformation. So this guy becomes org. This guy becomes okay, we made a mistake there. Okay, fine, no worries. So let's just do that again. This guy here, we want this to be, one thing I never understood with eShell is, for whatever reason, not seem to get history working properly. It's very strange, all my shells work perfectly fine on Emacs, but eShell, which is the shell I use now, history doesn't seem to really scroll properly. Right, now then, after a lot of strange problems, hopefully we can now compare these two buffers. So dia.log or .log. Right, as you can see here, for whatever reason, we still don't understand why, we seem to get more greps on the org version. Perhaps that's just to do with tracing. Fine, we have tracing enabled in one and not in the other, so that's fine. Okay. Alright, so you can see that there's already a few interesting differences, isn't it? We seem to have a profile as no base layer. Here's some noise again. Nope. So as I was saying, we seem to have profile as no base layer found on all profiles, which is rather different from what we see in dia. Okay, so that's definitely sounding extremely puzzling. Okay, well, let's just start by trying to understand why we have that difference. To me, that seems a good starting point for this investigation. So profile has no base layer, whereas this guy has a base layer name. Now, so how exactly does one get a base layer, I guess is the first question. So we ask for the base layer of the profile. Well, interesting that we seem to be making a copy of the profile here. So we ask for the base layer of the profile. So the key seems to be this bit here. PRP by stereotype find PDN. So the potential binding name in the profile repository and according to our log file, so I guess what we really need to understand is how exactly did this repository come to be, because it seems to me that the repository is not looking healthy. The profile repository, and it is not looking healthy. Just follow through how this PRP comes to be. This guy calls the bind. So here's the apply, here's the bind. The repository is supplied. So we supply the repository as part of the profile bindings transform. If we can find RG. Do a quick RG for this. So there's the variability profiles chain. Let's have a look at how the chain uses this then. So the PRP. Right, there we are. So profile repository production chain creates the repository. Well, let's have a look at what this guy is doing. Oh, okay, right, so fine. So all this is doing really is just instantiating the profiles and then doing a transform. Okay, so I guess one logical question to ask here is there any fundamental difference between the profile model? Yes, okay, I think I've got a way to ask a question here. So let's just say we go to tests, and on the diet test, we could just request tracing. Gonna make things a bit slower, but with a bit of luck, in fact we don't really need to run all tests, but there we go. So one thing we could compare, and the log file already revealed us something not quite right with the logging, but we need more details, so let's look at byproducts. So here we are, we have Dogen.json in here, and if I then have a look at his companion Dogen.dia, right, so then around here somewhere, let's just look at the codec transforms, right? So as you can see, we have a whole lot of codec transforms here. One of these is going to be profiles. Now, I think, if I remember right, the profiles was the last. Which kind of makes sense, because if you open up the Dogen model, you can see the profile is the last model being included there. So that's cool. Now let's imagine for a second that I JQ this guy here. And let's say I give it a nice name such as... I wonder if I can just rename buffer and call it dia profiles. Okie doke. And now we can do a similar exercise. Just have to make sure we don't lose track of where we are. So this is Dogen.dia. So right, I'm just gonna abandon. Oh no, actually we were in the right place. This is Dogen.org. Right, so it's very easy to make a mistake here. So interesting as well. Actually, I suspect. Okay, I suspect what we're doing here is not quite right. Let's just close. One of the disadvantages of tracing is that we generate directories every time we rerun. Sometimes we change the directory names and directory order, making it quite confusing. So that's the dia one. If I go to Codecs, here we are, and if I say profiles, it is very interesting that the tracing looks completely different between dia and... I wouldn't expect it to look too different. So if I say profiles here, as you can see here, I see the name profiles almost everywhere. Whereas if I say profiles here, I only see it in one place. Now this is very worrying. It means that the name of the model is not being set correctly. But we will have to deal with that later. So let's do another JQ. Let's rename this buffer and let's call this the org profiles. Right, so now then, after all of this pain, if we were to edit, so if I just edit buffers, so dia profiles versus org profiles, correct? Okay, that's very good. That means, I mean, if we did our job correctly, I mean, this is a bit surprising, in fact. We must not have done our job correctly because there should have been differences. So that's just unfortunately start all over again. Right, so let's make sure we are in the dia. Okay, we are. And then look for profiles. Here we are. Right, so that's going to give us the dia. Name buffer, dia, profiles. Now, let's start again. It just requires quite a lot of concentration. Let's try to concentrate. So we definitely got the dia. Now we just have to be clear, not making a mistake on the org. Right, so we're definitely on the org. That looks about right. Now if I just rename this buffer to org profiles and give it JSON mode, and look for dia. Now there's definitely have to be differences here. Okay, this is much healthier. So this is basically telling us what we're doing wrong. So a few things already. We're not reading the documentation, we're not setting the name of the model. The share pointers are... Okay, I wonder if not setting the name of the model. And now more significant differences start to appear. So this is a bit worrying. So, well, it could just be a question of ordering, to be fair. Right, let's just stop edit for a second. Are we recording? We are recording half an hour into it. So, right, so first, before we start to panic, the first thing we need to do here is to make sure that we are indeed in the same element, because this is not an ordered container. So it's entirely possible we're just picking up different elements. So the name of this guy is decoration. For some reason I can't spot the... Oh yeah, there's the name. And the name of this guy is base. Right, so I think what's happening at the moment is that we are skipping some elements. Let's just look for base here. See, as you can see, base is here. Yeah, there's quite a lot of things that look very strange here. For instance, the qualified name is base space. I wouldn't expect that, because if you look at it, it's only one, it's base. Ah, okay, base, so that's actually correct. Right, so it depends on what you mean, whether the base that we're looking at is... Right, so let's keep looking for base, because there's two bases, just to make things easier. Right, okay, I think this is the actual base, so... Okay, right, finally we got the right thing. So, so you already know that there's no commentary, so that's fine. The tagged values look healthy. The documentation is missing, we know that already. Yeah, okay, so I think the best thing to do really here is we're gonna have to eliminate all the differences between these two guys. Right, there's nothing obvious. I mean, you can see that things been missing. One of the things, so if we take a step back here, just try to come up with an approach. So we know at the moment that the model's coming out of the codec transform. So if you recap a little bit what we are trying to do. So you can see here, this is the tracing dump of Dogen. And it shows me for every transform, it shows me all the inputs and the outputs. And now we can just go quite quickly, just go to the top of the transform, to the end of the transform, and try to figure out what's coming out at the moment from the codec chain. And we can clearly see that there are differences. Now, I don't really know if those differences are causing the problems or not, but there shouldn't be any differences really. Or at least, to say the least, we should at least justify all the differences. So the first thing we're going to try to do then is we're going to try to eliminate these differences. Also because by eliminating the differences, we'll be able to then figure out if there is something that shouldn't be there, really. Even if some differences are just spurious. So that's what you're going to do. Now, however, what we... I think for this video, this is already 40 minutes, this is going to be a while. So what we'll do then is we will probably continue offline, because this work is quite tricky to do, really. So we'll probably continue offline and just go through all these differences. And I suspect that one of these differences, such as for example the name of the profile, is causing the binding to fail. So in other words, there is no name coming through, so therefore the binding doesn't bind, if you see what I mean. So yeah, that's what we're going to do. So we just stop for now and then resume when we get to a point where we figured out the problem. Thanks for watching.